Hi, welcome to another bioinformatics tutorial session. In this video, I am going to show you how to merge FastQ files. All right. So sometimes you can have a situation whereby you've been given paired reads like the one here. And then these reads come as multi-lane files. Okay, so here we see read 1, lane 1, lane 2, lane 3, read 2, lane 1, lane 2, lane 3. All right, so we are dealing with a multi-lane file. So I'm going to show you how to merge this file so that at the end of the day, we're going to get something like this, which represents the merged file. So that's what we are going to do. So for this tutorial, the only requirement is a Linux system. You don't need any other tool. Okay, so that's what we are going to do. You can also do it in macOS systems, but I prefer we do it in a Linux system. So let's proceed. So what we need to do is to first get the example data that we are going to use. I repeat, what we are going to do is to get the example data that we are going to use. That is these ones here. Okay, I'll show you where to get them. Okay, so let's open a new terminal. And then let's go to the GitHub repo, which has the data sets. Okay, so there's the page, and I'll leave the link to this page in the description box. So here you are going to find some links. All right. I have two samples, but we are going to use the first sample, which is from line 2 to line 13. Okay, these are the links. So we will use these links to get the files themselves. Okay. So what I want you to do is to copy from line 2 to line 13, everything like this. So copy it. Okay, we are going to use the terminal to download it. Alternatively, you can click on raw. When you click on raw, it will be sent to another page. Okay, and then you can copy the link. So we are copying from this side here to this side. Okay, so there's one sample. When we are done, you can try your hands on the other sample. That's fine. Okay, so for now, let's do with this sample, which is sample SR05. So let's copy the links. Okay, we have 3 lanes for each of the reads. These are paired reads. So we have lane 1, lane 2, lane 3. So take notes of that. Okay. So we are going to copy everything. Let's do it again. Let's copy everything. And then let's go to the terminal. So on the terminal, what I'll do is to create a directory, a working directory, right? I'll say make the FastQ files, and then I'll cd into that. Let's do an ls to make sure it's empty. Let's clear the screen. Okay, and then we can proceed. You can also do a PWD to see where you are. That's fine. I always advise you do that, right? Now that's what we are going to do. We are now going to download the files. Okay, what we got were the links. Okay, so we are now going to download them. So what I want you to do is to create a new text file. I'll say nano links.txt. Okay, so I'm going to open a new text file and then I'll paste the links in that. You can use Nano, you can use VI or any text editor for that matter. Right? But I'll use Nano, that's what I prefer. So nano links.txt, I'll open it and then I'm going to paste my links there. So these are the links. Okay, I have a total of 6, right? Now the lines that begin with hash, these are comments, so we don't really need them. Okay, but I thought I'll just bring them here so that we are on the same page. All right. So there's what I have. Okay. Now let's exit and save changes. I'll use Control X. I'll say yes. Okay, Y for yes. So if I do ls, I have the file there. If I do a cut, I'll see the links there. Okay. Again, the hash, these are comments. So whatever we are going to do will not affect them. They are not actual codes. They are also not links. So don't worry about them. It's just to let you know what these files represent. I'll clear the screen, do an ls again. Right. Now it's time to download. So for downloading, I'm going to use wget to download. All right. But if you take a look at what we have several links. Okay, so what we are going to do is to try to download multiple files at the same time. Okay, so that's what I'm going to do. I'm going to use sax. Okay, so I'm going to say cat lengths.txt. I'll bring a pipe and I'll say sax. Okay, I'll say dash I, meaning I'm going to get an input from this command. All right, so dash I, I'll say dash P uppercase, and I'll say 4. I want to download, I'm using 4 processes. Okay, and then I'll say wget, then I'll bring a single quotes, curly brackets, open close, and that single quote. So this is representing the inputs we will get here. Okay, all the lines, all the links. Okay, this represents them. Okay, so what we are going to do is to now execute this command to download the file. So let's do that. Okay, so everything is being done. You can see the progress also follow. So we can just wait whilst everything gets done for us. So these are small files, and so internet is not going to be an issue for you, hopefully. Okay, all the files have been downloaded. Let's clear the screen first. Let's ls. We are going to see the file here, right? Now I want us to organize the file. So I'll create another directory. I'll say make that all reads, and I'll move the FastQ files into the directory. So I'll say mven star, and I'll say .fastq.gz. I'll say all reads. Now if I do an ls, nothing is here. They are all in the all reads. So ls all reads, we are going to find them there. Now we are starting the main show. Okay, so the command we are going to use is cat. All right, now let's even look at the files that we have here. So if you take a look at the files, it's what? fastq.gz. So that means that these have been gz, they are compressed. Okay, so in Linux, if you want to combine or if you want to concatenate text files, we can use what we call cat to do this. Okay, earlier on I even did it. Okay, so we are going to the same cat command to merge the files. All right, but then if you take a look at what we have here, these are paired end reads. For each read, we have 3 lanes: lane 1, lane 2, lane 3. Okay, and so what we need to do is to make sure that we're able to identify some things here, some information that will allow us to merge. Now, this is where it also becomes important to have a good naming convention. If you look at this data here, all the read ones, they have what? This underscore R1. Underscore R1 is here, underscore R1 is here, underscore R1 is here. Okay, we need that information. We also know that the different lanes have their numbers. So L001 represents lane 1, L002 represents lane 2, L003 represents lane 3. Okay, so we have the information for lanes, we have the information for the read type, and of course, we also have the sample names. We also have the file extensions, which here is .fastq.gz. So everything is fine. So to merge 2 text files, okay, in Linux, you do a cat and you specify, let's say, file 1, file 2, file 3. And then you redirect to an output file. Let's say output file like this. So this is the rationale behind what we are doing. Okay, so we do a cat, we specify file 1, file 2, file 3. That's what we are going to do, right? So let's try this. I'll show you a couple of tricks also here. For now, let's try to merge the read 1, all the read ones. So if you are to merge, okay, as a beginner, you will say cat, then you specify all reads, then what? Let's just do copy and paste. You have to specify this, that's file 1, space, all reads, then you what? Specify the lane 2. All right, then all reads, then you specify lane 3. All right, and then you can now redirect. So if I redirect, I'll say what? SR05 underscore R1 FastQ.gz. Okay. Let me try to change the font size a bit so that everything fits. I'll try this and then we see. It should be here. Let's try this. Okay, yeah, this should be fine. So we are going to get something like this. So cut specify file 1, file 2, file 3. Then we bring our greater than symbol, redirect to the output file, like what I showed earlier. So this one works. So let's execute this command. Perfect. It's done. Okay, so this is a small file, so it doesn't take much time. So if it's a larger file, it will take some time, right? If I do an ls now, I'm going to see it here. Okay, this is it. Okay, but let's look at something here. If you look at this approach we use, it can be very problematic. If let's say you have several lanes, maybe lane 1, lane 2, lane 3, lane 4, lane 5, etc. And even with the 3 lanes, you realize, I repeat, even with the 3 lanes, you realize that we have what? All reads SR05. We have to copy and paste this. We have to do this. We have to do this. All right. This can be cumbersome. It can even lead to mistakes. But Linus makes it possible to do something simple. Okay. So I'm going to show you how to actually do this in a much refined manner, where we merge without having to specify all these things. All right. So again, I'm going to first remove what we did first, and then we are going to use that approach, which is very simple. Okay. So you are going to love this approach. Okay. Now let's ls again into all reads. We see our files there. I made mention for read 1, we have L001, L002, L003. The same for read 2. And so this allows us to use a wildcard to do the merging. Okay. Now, if let's say I want to get all read 1 files, this is just one sample. Okay, so fine. If I want to get all the read 1 files, I can just say ls all reads. I'll say star r1.fastq.gz. If I ls, I'm going to get all the lanes for read 1. Okay. I can do same for read 2 by saying r2. Okay. So we are going to use this principle or this trick to do the merging without us having to specify all the files. So that's what we are going to do next. Let's clear the screen. Let's ls into all reads again, and then let's do it. So now we are going to do the merging in a refined way. So to merge all read 1 files, okay, and before I even proceed, let me say that it's always important to have a good naming convention so that you're able to process files such as this. Okay, so we know that for all the files, we have what? A sample name separated by underscore, and we have the lane information separated by underscore, and we have R1, that is the read type, and we have this. So assuming that all your files have this naming convention, then it becomes easy to reproduce what I'm doing now. All right. Okay, so let's proceed. So now I'm going to do the merging. So what I'm going to do is to say cut, and I'll say all reads, and I'll say star underscore r1.fastq.gz. All right. Now, what does this mean? This means that all files, okay, all files that end with underscore r1.fastq.gz. That's what it means. So if I do this, that means that here, this one here, it ends with what? Underscore r1.fastq.gz. The same applies to lane 2. The same applies to lane 3. All right, so we have this pattern. So that means we don't have to specify everything. Okay, the system itself will automatically get all the files that fit this description, and then we can proceed. So now I do the cut, and then I redirect. So I'll now say SR05 underscore R1.fastq.gz. Easy. Let me just do it again here. So it's sr05 underscore r1 dot fastq dot gz, because we are merging read one. You can also add some description, maybe dot merge or something like that. That's up to you, but let's put it simple. Let's put it this way. Now let's execute this command. Nice, it's done. Let's ls. We are going to see it's there. Okay. Now let's do same for read 2. So again, we say cut all reads slash star underscore, and this time it becomes r2 fastq.gz. We redirect and we say sr05 underscore r2 fastq.gz. So ls, we'll do that after we are done with this command. Okay, so it's merged. So if you do ls, you are going to find the files there. Okay, it's simple. Now, after you are done, okay, it's always important to validate. Okay, so that's why before you maybe automate a script, you try with a single sample like I'm doing, and then you can validate to make sure the script is okay, then you can proceed. Now, how do I validate? I'm going to count all the reads. Okay, all the reads in the different lanes for read 1, and I'll do same for read 2. So ideally, the sum of this, all the lane ones, should be equal to what is here in the merge one. The sum of this should be equal to what you have in R2. Okay, so I'm going to do it now. So that's what I'm going to do. I'm first going to get the number of reads, okay, here in lane 1, lane 2, lane 3. Or let's say instead of number of, I can even say number of records. That's also fine. So here, the trick I'm going to use is that with FastQ files, okay, or yeah, we can just with FastQ files, okay, it can be large, so things can take a while. So you can just count just the first line. If I say zcat, okay, all reads sr05, let's say lane 1, let's say third minus n1. Okay, I have something like this. Okay, so what I'm going to do is to just count all the records here. That's what I'm going to count. Okay, so that it saves time. But you can also do the counting for all. That's fine. All the lines, that's also fine. So any of the approach should work fine for you. Okay, but I'm counting just these lines here because each FastQ file record, each record in a FastQ file begins with this. So if I count this lines automatically, I'm counting all the records. So that's what I'll do. But you can try by counting all the lines. That's also possible. Okay. If you want to count all the lines, then it's like this, wc-l. Okay, that will give you all the lines. Okay, so any of the approach can work. So now let's try to now validate what we have. So again, you can do this or do this, but now because it's a small file, let's even count all the lines. That'll be better, right? So let's clear the screen. Let's ls into all reads, and then let's count all the lines for this, this, and this. So for read 1, okay, let's say for read 1 lane 1, okay, I'll say zcat all reads lane 1 r1. I'll say what wc-l. Okay, this is for read 1 lane 1. Now for read 1 lane 2, that means you change just this one here. Instead of L001, it's L002. The rest remains the same. Let's count. It's also this, right? Now if you count, let's say lane 3. Let's try this. Okay, it's also the same. Okay, so by the way, these FastQ files, I did a subsampling, so that is why the numbers are all the same, so it's fine. So I have this. So if I sum this up, the total that I have should be the same as what is in the read 1 file here, the merge one. Okay. So first of all, we need to get the sum of this one. Say this is 1.4 1.4 million reads. So 1.4 million reads, if you are to sum them up, what will you get? Okay, let's use Python. I'll just count it here. 1.4 million reads times 3. It is what I have. 4.2 million reads. All right. So if I count this, I should get the same number of lines or the same number of records, depending on what you counted. Okay. Here, the 1.4 million here, it's not all the reads. Okay, let me just make it clear. It's not all the reads, it's all the lines. Okay, the reads themselves are also there, but these are all the lines, which includes other information. So this 1.4 I have here is the total number of lines in that FastQ file or in the FastQ file, because all of them have the same number. So the total number of lines. Okay, so for number of reads, there's a way to do it, which we can cover or talk about later. But for now, let's just focus on the number of lines, the ones we have here. That's what we are doing. All right. So what we have here, the sum that we have here, okay, should be what we have here. So I will say zcat, and I say wc-l. Okay, so that's what you have. So we should have the same number. If you sum the individual numbers up, you have the same number as the merged one. Okay. Now try for read 2. Okay. For that one, I'll leave it to you as an assignment. Try for read 2 and let's see what you get. Okay, read 1 worked. So the assumption is that read 2 also works. But anyway, let's try it. Since some of you may be beginners, it's important we try for read 2. So read 2, I have zcat. It's also the same. So all reads to wc-l. Okay. It's also the same number. Okay, so read 2 in 1, in 2, in 3. Okay, that's what I have. So if I sum them up, I have 4.2. So if I say zcat with 2 and I count the number of lines, I'm going to get the same, which is this one here. Okay. So that's what we have. And please take note that in this tutorial, the number of lines were the same for each of the files because I had these are FastQ file that I subsample. So I made sure to use the same numbers for the subsampling. Okay. But in the real world data, the numbers may be different. What you need to focus on is to make sure you are using the right command, and then you'll be fine. Alternatively, you can talk to an expert, or you can also book a session with me if you have such an issue to deal with. Okay, that's fine. Now, what we did was to just merge multi-lane files for a single sample. But if you have multiple samples, it's important to automate the process. Okay, so for automation, you can write your own bash script. I can also write a NestFlow script to do that. I already have a NestFlow tutorial. Okay, I repeat, I have a tutorial which shows how to use NestFlow to do the merging. Okay, as well as the NestFlow script. So if you are interested in that, you can check the description box for that video. You can also contact me to learn how to do that. So I'll see you next time.